In this tutorial, we are going to discuss the bonds about our cycle. Okay, so we've been given a question here. She's saying, draw the enthalpy diagrams for the formation of magnesium oxide and sodium fluoride there. Okay, from their elements and calculate the enthalpy change for each reaction. Then we have to show the changes that are involved. Okay, so now we've been given two molecules there, and we have to show the enthalpy diagram for the formation of each substances which have been given there. Okay, so now let's start with the first one, which is magnesium oxide. We show the enthalpy diagram, and then later on, we are going to calculate the enthalpy change for the formation of this magnesium oxide. Okay, so for magnesium oxide to be formed, we know that we need magnesium. Okay, so we have magnesium as a solid is going to react with half of the oxygen, okay, as a gas to give us what we call magnesium oxide. Okay, so this is the reaction for the formation of magnesium oxide. And we know that for this reaction to happen, the change in enthalpy is going to be negative. Okay, so it means that heat is going to be released for this magnesium oxide to be formed. Okay, so now let's show the enthalpy diagram on how this magnesium oxide is going to be formed. Now I'm going to work with magnesium and later on work with oxygen. Once I have the magnesium ions and the oxygen ions, I'm going to combine them so that I get my magnesium oxide. So we are working with ions, and if you check these ions, they're supposed to be in gaseous state, isn't it? Okay, so now let's start with magnesium there. If you check your magnesium, it's in solid state. Okay, so meaning we need to change its state from solid, okay, to a gas state, okay? And the process of changing a solid state to a gas state is what we call sublimation, isn't it? So this magnesium has to undergo what we call sublimation, okay, for it to form magnesium in gas state. That's the first thing we need. So we need it in gas state. So we're going to apply heat. So this is a solid. When we apply heat, it's going to change the state to a gas, and the process of changing a state from solid to gas without undergoing a liquid is what we call sublimation. Okay, so meaning the heat we are adding here is what we call the heat of sublimation, and when heat is added, is actually positive. Okay, so there we're going to get the positive change of in enthalpy of sublimation there for magnesium solid to be changed into magnesium there. Okay, so that's what we have. That's the first thing we need. Okay, so once we have our magnesium gas, the second thing that we need is the magnesium ion. Now, if you check magnesium, it has 2 electrons in the outermost shell, so meaning it has to lose those 2 electrons to form a 2+ ion. Okay, so we need to get a 2+ ion there. So it has to lose 2 electrons. Okay, so now there are some kind of energy that we need for us to remove those electrons from the nucleus. Okay, so now there's an energy you need to remove the first electron from the nucleus, and the energy that you need to use to remove the electron from the second electron from the nucleus as well. Okay, so let's start with the first one. Okay, so the amount of energy that we need when we remove the first electron from magnesium, we're going to get magnesium plus with the one there, see a gas. Okay, so now the amount of energy we need to remove the first electron is what we call the first ionization energy, and it's positive in this case because heat is added for us to remove that electron. Okay, so we're going to get positive first ionization energy there. Okay, so this is the first ionization energy, and it's positive. Okay, okay, so we are not done. Remember, magnesium, the ion is 2+. Okay, so we need to get a 2+ ion, meaning we need to remove another electron from the nucleus, and the amount of energy we need to remove the second electron from the nucleus is what we call the second ionization energy. Okay, so meaning this, when we remove another electron from this magnesium, we're going to end up having magnesium 2+ as an ion, the ion you want, okay? And we are saying the amount of energy that we need to remove the second electron is what we call the second ionization energy. And also here, heat is applied. So it's going to be positive as well. Okay, so we have our magnesium ion there, okay? Meaning we also need our oxygen ion. So let's give magnesium. Now let's focus on this oxygen atom. Okay, so now if you check this oxygen atom, is a diatomic molecule the way it is. There's two atoms. So we have 2 oxygen atoms there. But you are not working with the atomic molecule. You need what we call a monoatomic molecule. Okay. So what we are going to do for us to have a monoatomic molecule, to change the diatomic molecule to a monoatomic molecule, what we are going to do, we are going to dissociate this oxygen diatomic molecule. Okay. And the amount of energy that we need to use is what we call the dissociation energy. Okay, so the entire process is what we call atomization. Okay, so we're going to do atomization to this oxygen so that we get a monoatomic molecule. That's the first thing we're going to do. So it's already in gas state, no need of doing the changing of state. So we are going to go directly into changing this diatomic molecule into a monoatomic molecule. So we are changing this oxygen from O2 to O, okay? Still a gas, okay? And we are saying the energy that we need is what we call the dissociation energy. And this is half. Since there is half, we are going to say half of the dissociation energy. And the process is called the atomization, okay? So that's what we have there. Okay, so that's what we have. Then from this, we have now a monoatomic molecule. Okay, so the next thing that we need to do, we also need to get the oxygen ion as well. Okay, so we need to get the oxygen ion. You know that oxygen is 2 minus there. Okay, so this minus means that oxygen needs to gain electrons. Okay, so now the amount of energy that you need to add electrons to the nucleus is what we call the electron affinity. Okay, so now there is a thing with this electron affinity is that when you are adding the first electron to the nucleus, this process requires the loss of heat. So you'll be losing heat when you're adding the first electron to the nucleus. But for the second electron, notice that you need to gain heat for you to add another electron to the nucleus. So the first ionization energy, you can notice that it's going to be negative. And then the second ionization energy, you notice is going to be positive. Okay, so now we are saying we need to add 1 electron to this oxygen so that it becomes O minus. Okay, still a gas. And we are saying the amount of energy we are using to add that electron is the ionization energy and the electron affinity. Sorry, okay, and the first electron affinity is negative, so we are going to get negative electron affinity there. Okay, because we are losing the first electron. Okay, and then we are saying the second electron affinity. So that's the amount of energy you need to add an electron to the nucleus. Now we are talking about the second electron. So that one is going to be positive. So we are going to have oxygen. We remove or we add another electron. So meaning we are going to get a 2 minus there. Still a gas. Okay. And we are saying this energy is going to be positive. And it's the electron affinity there. So the amount of energy you need to add an electron to the nucleus. So you have 2 ions for magnesium and the ion for oxygen. You have the ions you want. So now you can add these 2 ions to form your magnesium oxide there. So let's get this magnesium ion and the oxygen ion. We add them together. We are going to form the magnesium oxide. Okay. So now there's also the energy that you need to add these 2 ions together for you to get the magnesium oxide. And that is what we call the lattice energy. Okay, so it is called the lattice energy. Okay, and it carries a negative charge because we are saying this process for us to form magnesium oxide, we've noticed that we are losing heat, isn't it? So heat is being released in this case. So meaning the lattice energy is going to be negative. Okay, so it's mostly donated by delta U. Okay, so you're going to have a U negative there. Okay, so that is energy. So this is the enthalpy diagram for the formation of our magnesium oxide, and we've showed the changes that are involved in each step. Okay, so now let's do the second part for the formation of magnesium oxide, which is calculating the enthalpy. So we are saying the change in enthalpy, okay, for the formation of magnesium oxide is going to be. So now when you have your enthalpy diagram, it's easy for you to calculate the change in enthalpy for the formation of magnesium. In that, you are just going to be adding the energies that you are having. Okay, so you can see there for the first one, so we are going to get the enthalpy change of the sublimation of magnesium there. Okay, so we get the enthalpy change for the sublimation of magnesium. Okay, plus then we get the first ionization energy for magnesium there. It's positive, so we're going to get the first ionization energy for magnesium. Okay, then we get the second ionization energy, which is also positive for magnesium. Okay, so this is the second ionization energy. We can get the half of the dissociation energy for oxygen there. Okay, and we get the negative of the electron affinity. So this is the first electron affinity, this is the second electron affinity. So we get the first electron affinity there, okay, which is negative, and then the second electron affinity we are saying is going to be positive. Okay, then we have the total. Okay, so we are adding the magnesium ion and the oxygen ion to form magnesium oxide, and the energy we are using is what we call the lattice energy, and it's actually negative. So we are going to get a negative U there. Okay, so now we can add numbers. Okay, so now we are going to use numbers from our literature, okay, to add what we are having here. So I'm going to use my literature to add the values that we need there. Okay, so and remember the change in enthalpy for these energies, the units are in kilojoules per mole. Okay, so that's what we have. So let's start with the first one. Okay, so we have the change in enthalpy for sublimation of magnesium there, which is actually 148. Okay, so that's 148, okay, kilojoules per mole. Okay, then we have plus the ionization, the first ionization energy for magnesium, okay, from your literature should be 736. Okay, so we have 736 plus, okay, then we are saying we have the second ionization energy for magnesium, which is 1450 plus, okay, we have the half of the dissociation energy for oxygen there, okay, which is 249. Okay, then we get the negative electron affinity for the first electron affinity for oxygen is negative 142. Okay, so we have negative 142 there. Then we get plus the second ionization energy, the second electron affinity for oxygen, which is positive. I put a positive there, and it's 770. Okay, then we get the lattice energy for the formation of magnesium oxide there, which is negative. So since we are having a negative lattice energy there, so we're going to get negative 3812. Okay, so these are in kilojoules per mole. Okay, so now we can calculate there. So we get our 148 plus 736 plus 1450 plus 249 minus 142 plus 770 minus 3812. Okay, so we'll get the final change in enthalpy for the formation of the enthalpy change for the formation of magnesium oxide to be negative 601 kilojoules per mole. Okay, so that's what we have there. Okay, so we are done with magnesium. So we're going to do the second part, okay, which is our, okay, so our sodium fluoride there, okay. So let's do the same procedure. We are going to follow the same procedure, okay. So we know that when we have our sodium, okay, we react it with it. So this sodium is a solid, okay. We react it with half of our fluorine, okay. This is a gas as well, okay. This is going to give us sodium fluoride, okay. So now we need to show the enthalpy diagram for the formation of this sodium fluoride. Okay, so follow the same procedure. Start with the first step, okay. Let's deal with sodium, then we'll come back to fluorine. That's how I do it, okay. So let's start with the first step, which is sodium. We deal with sodium. You know, like sodium is a solid. We need to do a gas state. So we are going to do the same procedure. We're going to change the state from solid to a gas. Okay, so we're going to undergo what we call sublimation. We will apply some heat, so meaning the change in enthalpy is going to be positive, isn't it? So this is the sublimation of sodium. Okay, then we're going to get sodium as a gas. Okay, once you have sodium as a gas, you need it to be an ion. So now sodium ion is 1 plus there. You know, sodium has 1 electron on the outermost shell, so meaning it needs to lose that electron for it to form an ion. Okay, so the amount of energy that you need to remove that electron to the sodium nucleus is what we call ionization energy. So that's the first ionization energy. Because you only have 1 electron in the sodium, you are going to have only the first ionization energy for you to form the sodium ion there. And this ionization energy is positive because heat is added for an electron to be removed from the sodium nucleus. Okay, so we have the sodium ion there as a gas. Okay, so we also need the fluorine ion. Okay, so here again, fluorine will be given as the atomic molecule, so we need it to be a monoatomic molecule. So what are we going to do? We do the same thing. We dissociate it, and the amount of energy we need is what we call dissociation energy in the process called atomization. Okay, so we are going to do atomization in this case. So we introduce half of the dissociation energy. Okay, so the amount of energy we need to break this fluorine atom into 1 atom, which is the monoatomic fluorine there, is what we call the dissociation energy. Okay, so we need half of the dissociation energy, and this is positive because heat is applied. Okay, so once we have our fluorine atom, the monoatomic fluorine there is a gas, we can change it into an ion. Okay, and we know that fluorine has 7 electrons in the outermost shell. So for it to form a fluorine ion, it needs to gain 1 electron. And we said the amount of energy we need to add an electron to the nucleus is what we call electron affinity. And for the first electron affinity, we are saying is actually negative. Okay, so here we are going to get the first electron affinity, which is negative. Okay, then we are going to form our fluorine ion there. Okay, we are still in gas state. Okay, so that's what we have. So now what we are going to do, we are going to combine these two, okay, for us to form the sodium fluoride that we need there. Okay, so we'll combine these two, and the energy that we need to combine these two ions is what we call the lattice energy. Donated by the TIU is negative. So that's what we have. So this is the enthalpy diagram for the formation of sodium fluoride there. And we've showed all the changes that are happening at each and every step. Okay, so now after this, we need to also calculate the change in enthalpy for the formation of sodium fluoride. Okay, so we are going to say the change in enthalpy for the formation of sodium fluoride is going to be equal to, so we add the energies that are there. Okay, so we get the first one which is the enthalpy change of sublimation there. Okay. Then we have the ionization energy, the first ionization energy for sodium. Okay. Then we have plus half of the dissociation energy. Okay. Then minus electron affinity, the first electron affinity, and then also minus the lattice energy there. That's what we have. Okay, so we can paste the values from our literature, and these are in kilojoules per mole. Okay, so let's do that. So we start with the enthalpy change of sublimation for sodium is 108. So we get 108. Okay, then we get the first ionization energy for sodium. Okay, so the first ionization energy for sodium is positive. You have a positive there, so it's going to be positive 496 there. Okay, then what else? We have the half of dissociation energy for fluorine, which is going to be 76. So this is half of the dissociation energy of the fluorine atom there. Okay. Then we have the electron affinity, which is negative. So the electron affinity there is going to be the electron affinity, the amount of energy you need to add the first electron to the fluorine atom is the negative 328 there, and the lattice energy for the formation of sodium fluoride is negative 929. Okay, so these are all in kilojoules per mole. Okay, so now we can add our numbers. So we have 108 plus 496 plus 76 minus 328 minus 929. Okay, so we are going to get negative 574 kilojoules per mole. Okay, so that's what we have. So we've showed the enthalpy diagrams for the two, and we've also calculated the enthalpy change for each formation of the substances we've been given. Okay, so that's all for this tutorial. So for more tutorial videos, if you want the whole solution for tutorial sheet 2, if you're at UNLAS, okay, so you can register with us. Let me just show you how you can register. Okay, so you open an account with us. Okay, so you can open your browser like that. Okay, so let me just show you. So you open your browser, you type Discrete Learning Institute. Okay, so you open the browser, you type Discrete Learning Institute. Once you open it, you are supposed to have something like okay. So you're supposed to create an account. Okay, so if you already have an account, you subscribe to the course of your choice. Okay, so once you subscribe for the course of your choice, for example, if you are subscribed to chemistry, you can open the chemistry folder. It will look like this. Okay, then you go where it's saying general chemistry there, you open. Then once you open general chemistry, you have these folders. You can go where it's saying tutorial sheets and assessment. If you want topic videos on thermochemistry, they are there. Okay, so you are going to find the whole topic videos for thermochemistry. Okay, so all these topics are there. They are decoded topics. So you can see there we have thermochemistry, which is here. Okay, so you can find more videos about this topic on lesson 17 there in the folder written 17 there. Okay, if you want the full solution for your tutorial sheet on thermochemistry, you go here where it's saying tutorial sheets and assessment. Okay, so you can open there. You are going to see folders for different universities. So if you are UNLAS, you open UNLAS there. Then okay, so you're going to see the two folders for the semester. Okay, so if you're in second semester, you open second semester. Then you're going to see the intake. So there's July intake, and January intake. Okay, so you can open for January intake there. You are going to find the toy sheet solutions for thermochemistry and thermodynamics, the full video solutions. Okay, so you will find all the video solutions in that folder. Okay, so that's what you do. Okay, so you find the full video solution in this folder written to sheet 1 there. Okay, so you find the video solutions there for the whole tutorial sheet. Okay, so thank you so much for watching this video.